Okay, now let's see what a crossover does to our woofer. So this is the phase response of a woofer in a ported cabinet, or even if it was a sealed cabinet, would be the same thing. Just the lack of the tuning frequency, the tuning from the box would place the phase reversal point to a different point. However, here we do not have a low pass crossover, so the upper range of the frequency is at 0 phase. Now let's see if we add the first order crossover, then you see it will take the phase out to minus 90 degrees. So now it's a first order crossover at 500 Hertz, f minus 3 dB frequency. And so you can see here, so the crossover point is right there where the arrow is, and by that time already we have a minus, what's that, minus 30 degrees out of phase response by the time we are crossing it over, and then it will just go down to minus 90. Now let's see what happens when we add a second order crossover. Same frequency, 500 Hertz. Now it's much more steeper. So you see, now we have basically 0 phase, only around 200 Hertz, which is like half of the crossover frequency. And by the time we hit 500 Hertz, what do we get? Almost minus 80, minus 75 degrees out of phase. That's quite drastic. And if you go to higher frequencies, and I would say like 500 is critical because there the woofer is still strong there, and it's giving you 75 degree out of phase information. But even at 1 kilohertz, 2 kilohertz, it still contributes a lot of signal to mock up the region, and there we have minus 155 degrees. So like almost like completely out of phase information, but not completely. If it's completely out of phase, then the sound will become a little bit quieter, and it's easy to plan with that. But because it's not exactly 180 degrees out of phase, it will just mock up the sound. And that's why when you go from a second order crossover and you just use a first order instead, because the phase change slope is much gentler, it's going to give you a much more natural sound. So especially if you are listening to violin or cello or vocals, this will be a major improvement. So if you have a problem that you have low intelligibility from the speakers, so someone is singing and you cannot really get the words of the song, that's because the slope for the crossover is too high, and because of the big phase step, it's the brain cannot really process the information, because if this was by itself it wouldn't be so bad, but we are meeting it with the tweeter or the high frequency driver, and the phase issues with the two are just way too big to deal with. However, now let's have a look at a third order crossover, because in commercial speakers we can often see third and even higher order. Look, so now by the time we reach around 800 Hertz, there's a complete phase reversal. It's a mess, and you would say, oh, it's okay because at third order the slope is already 18 dB per octave. But look at that. So at 500 Hertz, it's still just minus 3 dB, and we are already at minus 120 degrees. So it's really flipped out of phase by the time you are crossing it. So it's a huge problem. And now let's have a look at fourth order crossover. Now this is even worse. By the time you reach 500, you are essentially out of phase at the place where you are crossing it over. And speaker designers or just general advice, oh, it's easy, just flip the next driver out of phase to mate it. But the problem is not that. The problem is that the phase change is so abrupt that we go, this is like 0 phase level, and then you have almost no information, which is plus and minus 30 degrees. So this is the useful range that would give you like a reasonably phase correct information, and then you have for that maybe like less than an octave. That's a very completely useless material. I mean, completely useless range. If you have a first order crossover, then this nice and gentle slope will give you a normal transition. So thing with phase is not just you want something phase correct, but in reality there's nothing that's phase correct. You just want something that is close to phase 0 and has as much material as close to it as possible, and that's what we call phase correct. The only thing that can be truly phase correct is electrostatic speakers. Then you can have a much better shot at it. So I hope this helps a little bit to show what issues we face when we look at phase. So what we should do as designers is try to use as low order crossover as possible, because then you have the best phase response characteristic, and this is absolutely vital for good musical sound. Speakers sound so mechanical because they use second order and higher order crossovers. This gives us the impression that the sound is more controlled, but it will sound more mechanical, and that's because the phase changes are so abrupt. Still, when you add the speaker drivers together, at the SPL meter you can have a nice and flat SPL level, but when you look at the phase response, it's a nightmare scenario. So please like and subscribe, and I hope this gave a little idea on how the phase response works when you add crossovers to a woofer. Thank you. Bye bye.